The conference has been muted.
Okay, again, good day everybody. Today I'm going to talk about an advance in pyrometry for aluminium applications. Okay, for some very exciting information on this. The most difficult common metal to measure by non-contact means is aluminum and its alloys. Aluminum now is the second most popular metal in the world to be used in daily life, only beaten by iron and steel. However, aluminum has very difficult characteristics which evade temperature measurement by normal non-contact means. And so not only does aluminum have a very low emissivity value, but that value can vary slightly with alloy grades or the surface finish, the measurement wavelength, and also any slight amount of oxidization on the surface. So conventional pyrometers really fail at being able to measure this material. I'll give you an idea. The common 6000 series of aluminum alloys typically have an emissivity value around 0.1, can be lower. So that means that they are only emitting 10% of their energy. And emissivity is 1 minus reflectivity, so they are also extremely reflective. Okay, and this poses certain challenges. So I've mentioned conventional thermometers really have a very hard time trying to measure aluminum at all. Some people have tried using ratio thermometers. Some people refer to them as two-color thermometers, and they are also unsuccessful because the emissivity at the two wavelengths that those devices use varies at different rates, and the results you get are quite bad. So we've recently developed a pyrometer which we call SpotAlEQs, and it's a multi-wavelength design, and it not only is a multi-wavelength design, but it also has intelligence, computational capabilities to make sense of the various signals that it's seeing and to actually uncover the real temperature measurement within the scene. And it does this automatically. So Land first produced aluminium specific pyrometers back in the early 1990s, and this was as a result of a lot of research and development that we'd done along with a number of aluminium producers. These thermometers were very successful, and in the late 1990s we developed a second generation of them which offered improved processing and better adaptability to different alloy types. The SpotAlEQs now improves in a lot of ways. The first thing is that now the SpotAlEQs thermometer has digital processing within the thermometer, very powerful multi-core CPU with digital processing, and complex radiance, emissivity and temperature computations are continuously performed by SpotAlEQs in its high-speed digital processors. So this thermometer can be used in 3 different applications. The very same thermometer in 3 different applications. It can be used by extruders at the extrusion press exit. It can be used at the quench exit position. And it can also be used by aluminium hot rolling mills at the mill entry and the mill exits. The overall temperature range of this thermometer is 200 to 700 Celsius, so it's quite a wide range. And because there's only one thermometer to do all of these measurements, if for instance you're an extruder and you have a number of presses and you want to keep a spare thermometer, you only need to keep one because you can use it at any location. So you simply select application mode E for the extrusion press, or Q for the quench exit, or S if you're in a hot strip mill. And then aim the thermometer at the product, and the thermometer does everything else for you. It calculates and applies the correct settings automatically. So it's very easy to use. It combines high precision optics with very sensitive detectors. And again, I've mentioned that we have high speed computational capabilities because of the multi-core processor within the thermometer. And this combination really allows this thermometer to perform with very high accuracy and high speed in many more varied situations compared with previous designs. So for extruders, the ALEQs will accommodate partially filled target areas. So if an extrusion is only partially filling the view of the thermometer, it will measure accurately. It will accommodate varied alloy types automatically, and it's good for flat and also cavitated extrusion sections. In fact, 95% of today's alloys are accommodated automatically by the unit straight out of the box with no other settings. If you do come across a rare alloy type, it's very easy to teach SpotAlEQs to accommodate it. And you simply take a contact measurement of that rare material, and then using the Spot Viewer software, you enter that temperature and it pulls the computational algorithm into a different shape to accommodate it, and from that point on it will work very well. Here you'll see this is a typical schematic of an extrusion operation, and you've got a billet heating furnace. Land has a device called an ABT, an aluminum billet thermometer, which is used on the billets. And then SpotAlEQs would be used at the press exit, also at the quench exit positions. And in fact, if we use a speed transmitter, we can integrate all of these measurements together into software, and we can do quench rate calculations and other things. So let's talk a little bit more about SpotAlEQs and its capabilities. It includes a built-in video camera, and this is very useful for aligning the thermometer. You can see this video view either locally on the back of the thermometer or over a digital connection into a computer. The thermometer's also got a built-in web server. And so if you connect to it with its Ethernet connection, You can fire up your web browser, like in this particular case Firefox or Internet Explorer or any other web server, and you type in the IP address of the thermometer, and you get this web page appears of the thermometer, and you can press the buttons and you can configure it and do everything remotely. You can also view what the thermometer is looking at through its onboard camera. Also within the thermometer, you're able to set it up in local language configurations. And so, unlike analog designs and older designs of thermometers, regardless of where you are in the world, you don't have to understand English. So you can set this up in, in Spanish or French or Italian or Chinese, Korean, Japanese, Russian, which is this example, Polish, so many different language choices. So the thermometer itself has got adjustable focus, and it's a motorized focus as well. You can set that focus at any distance from 300 millimeters to infinity. Very easy to set the focus. And additionally, the thermometer has a patented bright green LED target pattern, which pulses when it's turned on, and it's very easy to see where the thermometer is looking at, but not only where it's looking at, but the size of the spot at that location that's being measured. And so in this particular example, this small circle in the center is exactly the location and the size of the measurement spot. Here you can see on, this is a press exit, and you can see SpotAlEQs targeted on the extrusion as it's coming out of the exit. Importantly too, because it's an LED, there's no laser safety issues. And so it's quite safe. You don't need a laser safety officer to inspect it or look at certifications because it's not necessary. Okay, so here we see a SpotAlEQs mounted on a simple mounting bracket above a press exit and looking at the extrusion as it comes out of the exit. Okay, and again, you can see there that target pattern that's been turned on to verify the alignment is on the right thing. Importantly, with this thermometer, in our design, we've made it capable of surviving much higher ambient temperatures, and so that we can work up to 70 Celsius now with these thermometers without needing any coolant on it. If you go above 70 Celsius, then we have other mountings which can protect it. But in many cases within the aluminium industry, 70 Celsius is very common, and you can survive very well without having expensive additional mountings or services. The thermometer itself is sealed very well to IP65, which is NEMA 4, and the protection window on the front is sapphire, so it's pretty much impossible to scratch that window unless you're scratching it with a diamond. And here we see one installed above this press exit. If there's a lot of dust or dirt in the atmosphere on the application, then we have an air purge accessory that fits onto the front of the thermometer very easily. Okay, and the air purge, the design of it is such that it's tolerant of instrument air. So if that air has not too good filtering, if it has oil droplets or whatever in it, that air never comes in contact with the lens of the thermometer. It projects forwards of the lens, and so it's a very good air purge for using available air. If you're in a very warm environment, then we have a rugged mounting accessory here which has a built-in air purge, but also a cooling jacket and then a protective end cap to it. Okay. This is shown also at another plant on a press exit application. If you've got older land thermometers, the previous generation, the ones we call the AET or the AQT, you don't have to buy new mountings. We have an adapter kit that adapts the spot thermometer to work in those existing mountings so that you're not paying for a new set of mountings again. It's very easy to use Spot because it has a lot of connection options. It has a current output which can be set as 0 to 20 milliamps or 4 to 20 milliamps, and that output is scalable anywhere within the range. It has an Ethernet output, has a Modbus TCP communication output. There's a command input for activating the LED. There's an ambient alarm output for the thermometer's own temperature, so it could warn you if it's going over temperature. We have a remote position output. We have a milliamp emissivity output, so the instrument is constantly measuring the material emissivity and giving that as an output. In this particular case, you can see in this image, in the distance you might be able to pick out that spot thermometer at the press exit. And back at the operator position, here's an Allen Bradley PLC, and they have it communicating directly with the thermometer using Modbus TCP. Okay, very easy to integrate into existing control systems. In addition, if you want something separate, the separate input from this can go into Spot Viewer software. And Spot Viewer software will allow you not only to see the temperature that's being measured, but also to data log it, to trend it. Okay, so it gives you a lot more features than just looking at it on a web browser. And in addition, the Spot Viewer software, it works with one spot thermometer at a time, but it's free. It's a free download on our website. The next one is what we call Vivid IR software, and our Vivid IR software will allow us to connect up to 40 spot pyrometers simultaneously, and not only connect to them simultaneously, but also be able to display them, trend them, data log them all simultaneously. Okay. The software is also Windows multi-monitor compatible. So in this particular case, we've got 20 thermometers being displayed here, but on a second monitor we can have another 20. So that's Vivid IR software, which is available. In addition, we have Spot SST software. And Spot SST software allows us to generate a custom piece of software to use with spot thermometers. In this case, we've seen that we've dropped in a graphic of the customer process and the positions of the different thermometers. Okay, and so when an operator looks at this HMI display, it's very easy for them to understand which thermometer they're looking at. And also in this particular case, because we've got a speed transmitter on the press, we're able to calculate the quench rate on this extrusion. So, the flexibility of this thermometer suits many different aluminium applications. As I mentioned before, both the extrusion press exit and the quench exit positions. And if you're on a hot strip mill, then the mill entry and the mill exit positions. It's got great accuracy straight out of the box. All you need to do is just select whether it's operating in E mode for the extrusion press exit, or Q mode for the quench exit, or S mode for a hot strip mill. The unit has built-in high-speed digital signal processing, and it's got a very tight optical system, very small spot size at distance. Even at the low end of 200 degrees Celsius, it's still a 60-to-1 field of view, which is a very tight field of view. And we've got this motorized adjustable focus that allows us to optimize the spot size at that particular distance. Additionally, we've got a very fast response speed of less than 15 milliseconds. Okay, so for a thermometer for this type of application, this is a groundbreaking response speed. Very, very rapid indeed. As I mentioned before, we've got multiple different digital and analog outputs. They're all included within the unit. And then to power it, you can either use 24 volts DC, or you can use power over Ethernet. And if the thermometer is being powered by both, it doesn't mind. It accommodates both of them. So it's easy to configure, very easy to configure. You can configure it locally on the back of the thermometer. You can configure it remotely through a web browser or through one of the other Windows pieces of software. And then it's very easy to tell where the instrument's looking at. You can either look locally at the view on the product itself with the LED targeting, or you can look through the back of the thermometer and see the video view of it, or you can see this video view through a web browser or the other software packages that we have. So just to round up here, this thermometer is for extruders at the press exit and the quench exit positions. It's also for aluminium hot rolling mills at mill entry and mill exit positions. It's got a wide temperature range. It's the same one pyrometer for all of those different measurement applications. You just simply select which mode it's working in, whether it's E mode for the extrusion press, Q mode for the quench, or S mode for the aluminum hot strip mill. Okay. After setting that, you just aim it at the product and it works. So what I'm going to do right now is I am going to open up the audio so that you're able to ask me questions, and I'll try and answer the questions. In addition to that, I will save the recording